Let's fix that. Good afternoon, ladies and gentlemen. How's everybody doing today? Okay, thank you. The energy, look, hey, I know it. I understand it. I get it. Fall break. I know. We all want it. I get to have a break too, right? Because I don't have to show up and deal with y'all for, Monday, right? So I get it. But we're not there yet, right? Just because that nice little, break point is very close at hand. We got to keep on going. We got to keep making that push just like we always have to do. But what I will say is at least what we're talking about today is it's not that we're wrapping up our logic section. We still got more to go, but the hard part of proofs is done. So you can, nice little sigh of relief. No more proof by contradictions. At least not today, right? I heard that and I liked it. So here's how I will kind of present this. Show of hands, who here is a double major? Right? Make it a little higher so everyone can see, right? I was a double major, don't knock it, right? You're trying to learn two separate things, right? Why I kind of bring that up is for the rest of you. It's not that I'm knocking you either, but I want you to realize something. All you are computer scientists, right? No, I saw some looks of like, no, I'm more than just a programmer. What I'm trying to say is like, well, who here is becoming a master biologist, right? Who here is becoming a master chemist or a nuclear engineer, right? All of those other things that we also teach here at NC State. And why I present that is, remember, a lot of what we're seeing with AI right now is specifically, how can we use it? How can we use it everywhere, right? That's the big push right now with artificial intelligence is like, hey, we have this thing that can solve everything, right? We have these mathematical programs that we can develop, but remember, think about how you've had to develop them, right? It's, them, you understand them. It's lists, it's Connect 4, right? It's these types of agents and programs that are something that is tangible to computer science. But the problem is, as we move out of computer science and move into the big, buzzword of the era known as interdisciplinary work, right, where we have to work with other people from different organizations, I don't know a thing about nuclear reaction, period, right? Who here does? If you do, that's cool. But I don't. But how would I build a program now to work with that, right? How do I build a SCADA system that connects and interacts and displays the right kind of things? I don't even know what sensors they use in that field. And so that becomes one of our sort of challenges, not only as AI, but as computer scientists as a whole. How do we try and take what we know and apply it into these different kinds of worlds? There are some things. This is where I like to talk about this. If some of you've sat down and maybe had a meeting with me about what do you do after college? I'm more than willing to kind of share with you the heartache of reality. But when we think about outside of computer science, right, when you're no longer doing Connect 4 types of assignments, when you're no longer doing these nice little simulations, one of the things that you start to look at is, what do I want to do with computer science? What do I want to do with this skill set that I have now acquired in the past 4 years? And when we think about those real world kind of problems, right, those are a little bit different because it has a lot more context to it that we don't have time to teach you, right? Diagnosing a patient's condition based on biometrics, right? Same kind of thing of just who here was a double major, someone identified that. But, I'm not going to pull names for anyone of who's been, recently just clipped up and hooked up to the hospital stuff. All right. But you got your heart rate monitors, you've got your O2 sensors, you got your temperature. That's only the ones I remember off the top of my head. All of those are monitoring you at, on a second-by-second basis. And that's how we can kind of do things like, oh, can we detect sepsis? Because sepsis, if it is, what's the word I'm looking for? If we start to see the onset of sepsis, the issue with sepsis is that it is very rapid and deadly. So like as soon as those symptoms pick up, if we don't like address it immediately, the patient will pass away due to sepsis. And so, right, we as computer scientists never really sat down to learn the symptoms of sepsis or how the body worked. But we are being asked, hey, do you know AI? Can we use AI to catch that stuff? I mean, I think so, right? And in fact, that's what research is doing right now. That is what, there are some of the faculty here in the computer science field, they've taken our skill set and they have applied it to medical, right? This idea of just medical. Then we've got things like anomalies, right? This is where if you're looking at it from a security perspective, maybe some of you are always thinking it would be cool to have something that can trade your Dogecoin. Is Dogecoin still relevant with? I don't think it was ever relevant. I think we all just always make fun of it until someone becomes a millionaire from it. And then we're just like, right? I think that's how we feel with crypto. It's just we're mad the thing I have $100 in isn't making me a millionaire. Either way, right, again, so we want to see, hey, when do those signals change? And that's, not just, again, for financial analysis, but also, again, that is for security analysis. That's for hardware. Anything that's, just a channel, right, is giving us some information. Locating missing individuals and persons of interest. Like I said, that was my master's degree. I was catching bad guys. But we also now are, only 2 weeks out of Hurricane Helene. We got Milton that is kind of looming over everyone's shoulder, and we're all kind of waiting to see what happens tomorrow with that. And yeah, right? How do I find them? What metrics can I use? It's not just, I can program really quickly, in an efficient algorithm. It's like, what data do we have available, and what can I do to actually find those people, especially when we think drones in the sky, infrared cameras, things like that. And then, ChatGPT, predict next expected word, right? That's all that we still just, you've all learned that ChatGPT isn't good, right? But you see the air quotes there. It's pretty damn good. But now that it's pretty damn good, we're nitpicking on it. We're like, it's not quite good yet. It's not smart enough to solve a math problem. It is now, right? All of these things are real world kind of context. And so how do we do this, right? This is that thing that we have held over your head the entire entire time you've been a computer science student. We always talk about this big word, problem solving, right? And yeah, here's your steps to do it. The big one is you have to constantly tweak and fiddle. How often do you think I have fiddled with your slides? Every semester I have changed and fiddled and tweaked and looked and, it is just a constant iteration because, right, I'm still trying to, my real world problem is, as an instructor, is how do I get y'all to know this material, learn this material? And so I have to iterate on that entire process. So what I'm going to do is I want you to start today with, we're not going to, I'm going to keep it open. That way y'all can think of it. Think about an industry is how I want you to, an industry and an area, I'm calling it a problem domain. Like, where would you like to apply AI? Is specifically what I'm doing. And I'm giving you some higher level kind of categories, but I want you to go a little deeper than just like, I want to use it for medical, right? Think about it doesn't have to be anything, pie in the sky. Everything is your oyster right now, right? Again, We don't know where ChatGPT is going to take us. We're in the future now, right? Robots exist, and right, Disney makes robots, right? So play your favorite science fiction author for a second and be like, oh, in the medical field, I want to identify the proteins that stop cancer, right? Something like education, industrial, financial, entertainment. Some of y'all, again, I have a lot of game development students in this course. That's just going to keep going up. I see the game development conference T-shirt. Yeah, guess what? That's just we like that. Humans like that stuff. Defense and security, anything. Some of y'all maybe just want to do sports analysis with this, right? Have fun. Pick one of those. And why I present that is now, as I ramble today, I want you to kind of keep that in the back of your head. Of like, here's the thing that I would be interested in doing AI with. And now here's me trying to, piece and shoehorn it in as we talk about knowledge representation. Because that's, again, you only are going to be able to apply it in areas that you understand. Or have some kind of knowledge with, right? So just something to kind of stew on. So we're going to take like another half a second. I'm rambling, and that's mostly so you can continue thinking. Have you all got your things? Good. All righty. So again, when we start to think about knowledge representation and what does that mean? What we're specifically kind of trying to do is, this is something you've heard me say a few times over the semester so far. It's this idea that we're trying to take some piece of our knowledge, something that we as humans know, not just a physics engine, not just STEM, where it's literally just here's the chemical reactions of something and how it translates, or here's what gravity does. Yeah, sure, all of that's great, but that's a simulation, and yes, it kind of falls into the AI umbrella, but when we start getting into that higher order type of stuff for human needs, the thing that we have to think about, right, just like did curiosity kill the cat, we need a way to model and represent that in such a way, model and represent our human understanding of the world so that a computer can understand it. Because again, the computer, you learned this a long time ago. Computer's very dumb, right? Super dumb. It just does what you tell it to. And sometimes we're dumb too, right? I've told y'all I'm pretty, I went like this on Monday, right? That happens. Now, with that in mind, that's where when we start kind of breaking down our own problems in computer science and what we have to solve, it breaks down, right? Most of our stuff outside of AI falls into the data structures workflow environment. How do I manage, how do I kind of get data from one point to another, and maybe some math equations along the way, right? 316 land. You learned what 316 taught you. You became very familiar with every data structure out there, right? For good reason, right? It's a very powerful tool that we have the ability to handle collections, right? Lists of numbers. We are going to be using lists of numbers. But when we start thinking about it from AI solutions, right? That was computer science solutions. Now we're dealing with it of specifically, okay, well, agents have these data structures. Now what, right? And that's where we move sort of to the next level of our kind of our computer skills, right? That's where we form a big new fancy word, ontologies. This is the language that this field or a particular area domain refers to, talks about. Again, I've talked about how I do martial arts. Some of you, again, very excited about video games. I have my own ontology for my space, right? Taking ukemi, making sure that I can do a proper tenkan, right? Those are words that, right, they're Japanese words, and I'm saying them completely wrong, right? But those are words that I understand because it is my domain. PvP, FPS, dots, right? All of those things are video game terms, and if you don't know what they mean, right, you have to remember that these are terms that we use in those spaces. And why we kind of mean that is when I'm keeping this high level because we actually got to start high level. We can, as computer scientists in our own, precious little world, can represent anything. Think about all the programs that you've written through all your courses. You've represented a lot of different things. And in fact, there you go. I represent anything. Okay, that's too generic though, right? I can't do much with anything. I need a little bit more tangibility. And this is where I'm at least drawing from the textbook a little bit, where they kind of start to break it down, is there are maybe, abstract objects and generalized events. Now, when we think abstract objects, we're not talking about like tangible objects in this sense. We're more referring to that as sort of ways to categorize or measure those things, right? If you look, as you break that down, we're talking collections, and those collections can turn categorical. Or I need to be measuring things based on how much time it takes or how much it weighs, right? Weight could break down even further. Give me a weight. A unit of weight there. Kilogram, well, just gram, right? We don't even need the kilo. Another one. Pounds, right? Give me one that could also be a different form of weight. Huh? Newton, there we go. Sorry, I heard YouTube and I was like, I don't understand, right? Yeah, Newtons, Fahrenheit's, Celsius's, Kelvins, all of those are essentially a form of measurement that we could be working off of, right? And so this is where, hey, you heard this. You learned this in CS 116. Everything in Java is an object. Maybe you heard that, or you've heard that joke before. Because, yeah, everything, that's the entire point of our higher order programming languages is object-oriented programming. Everything is an object. When I want to build a GUI in Java, right, if I would need that password field that has its own, it won't show you the password, right? It'll only show you kind of circles, right? Well, that's, again, I'm just trying to represent this thing. And well, what is this thing? Just a text field with a little extra bells and whistles going on. If I look at a text field, well, a text field is just a form of input that I want to be able to have the user work off of. And if I want to think about input, well, it's really just a control mechanism at the end of the day, a much more higher. Notice I'm getting more vague with my statements, but what is a control mechanism? It's just some form of, I don't know why Java does parent as the terminology. I don't know, pick one. But all of that, again, starts to get back into this idea of it's just a generic thing, a node, right? Why we talk parent is, now that I'm remembering, it's more of like the hierarchical of where something belongs. But you can see, again, think about just trying to represent this. That's inheritance that we're essentially coming back to. But then when we start thinking about the other side of that, we also have generalized events. And again, this is where I will say it's a little confusing. It's a little jarring to the brain. But abstract objects was, again, just talking about more of the like abstract concepts around an object. Generalized events, you might notice, are actually like the liquids, right? Or the solids or the gases. I was thinking in my head, we were talking kilograms. Like that was a unit of measurement for a thing. Solid is the thing suddenly. I know that's where, even though it's called a generalized event, how I can kind of frame that is, yeah, technically generalized events are physical objects. A way you can think about that, again, if we're representing that, this is where we are still kind of working in prologue territory, right? I could, in theory, represent that, hey, where is it? For the semester, I know that should be a 4, and that should be a fall, so. I totally upgraded these to your semester, right? For the semester of fall 2004, that would equal whomever is the instructor for CSE 411 to Adam Gaweda. That should equal, right, for that semester. Well, again, this is kind of it's just a moment of time. Something is existing at a particular state, area, thing, at a moment of time. That's actually really interesting, right? Think about time for a second. Have you ever just sat down to think about time? How would you model time? This is where we get into some of that kind of fun, just like playing with what we can do, what we can represent. Because think about, again, I'm going to just continue saying it. Think about time for a moment. When you state that you are going, I have to do a thing before a thing, right? Let's hang out before CSE 411, or let's have a coding practice session never during, right? After CSE 411, right? You're establishing you want to have an event, a thing, right, occurring before another thing, my course, right? And what does it mean? What are the rules that we use as just humans to dictate before, right? Just that concept of before. Well, if we have two events, I and J, right? If we have just that before going on, before I and J, that's not how you do a J. Right? What am I trying to say here? Oh, well, I needs to appear before J. What does before mean? Well, again, it's a more tangible thing. It doesn't need to be immediately before. It just needs to be some moment before, right? Some kind of time concept. I like to kind of visualize that as here's my I, right? It has some start time. It has some end time. But then I'm kind of saying, or I'm trying to make this kind of representation that, hey, if I'm using this sort of block structure to indicate the starting point and the ending point, I'm probably going to want to do the exact same thing with my J. And wouldn't you know it, it has its own starting point and its own ending point. So that rule that you see up there, right, where I'm saying, oh, end must be less than the beginning, it could technically, right, if we really want to split hairs, it could technically be less than or equal to, but all I'm really trying to get at is this number needs to be smaller than this number, right? That's kind of an interesting thing. And then you can see there's an entire deep dive. Literally, it's a little older of a paper, but there's an entire, okay, I'm just not gonna. No? Okay, you're not gonna, there it is, right? There you go. That little thing is a link. If you really are, wanna have a super, super fun fall break, here's a 26-page paper on representing time theoretically. Hey, some of y'all, I've talked to you, that you're like, all right, I'm into it, right? So yeah, it goes even deeper. It talks about, there's all of those different things. So by all means, and so again, you can represent all of them. These are all now visualized. So yes, I had that before, but you can see what happens when they meet each other, or when something is during another thing, or when something overlaps with another thing, right? One of them has to overlap. It doesn't need to be both. What happens when they start at the same time, finish at the same time, or are equal to each other at the same time? This is where, who here took me for 116? Any of you, because I know some of you are in the class, they just chose to not attend. We got to talk to them. I know you're watching this, because if you're not, you know I'm not happy. 1/16ers. Okay, right? Why I mention that is I actually make them, this is one of my assignments for them, for my 1/16. Congratulations, welcome to objects. Build these as methods, right? Because, because you can represent these things, you can build these things. And why I present that is now, well, what can we do if I have the concept of time? Well, the concept of time is just one type of representation, and then maybe with that same kind of thing, I could represent what the things that are happening before or during or after a thing could be. And this is another paper, a little earlier, still kind of old in our kind of concept of like research, but oh, look at that. Using a big fancy $5 word, event calculus. Ooh, right? Using building out a mathematical way to represent events. And specifically, why would you want to represent events? Well, in this case, what they're doing is they're kind of trying to provide a way to do analysis on system workflow. So some of you, maybe you're just thinking, oh, computer science, that's the only thing I care about, right? I just want to build cool programs or, make a lot of money. Cool, guess what? Here you go, look at this. You can see that, hey, those are still rules, like A initiates B at time T, right? Event A initiates the property of B for all times where T is, for all time greater than some starting point. And why do we present these different things? Again, this is not like you have to build them or anything, but it's presenting them because what we can do with that, and this is me, just kind of, it's a really good paper. It's really interesting and fun to read if you like to read research papers leisurely. That's why I'm a professor. My point being is like, oh, well, if you dig a little deeper into it, specifically, they start going in and look at that. That's just prologue statements. Prologue rules suddenly are being formed where maybe something is a member of a domain, right? A thing, an object, is a member of a domain. One domain may be a subdomain to another domain. Right? It's actually building out these different rules for sort of the relationships between certain things. And why I present that, right, is let's talk about printers. Right? Printers. Why would I want to talk about printers? Well, printers cost you money. And again, if you're going into like that field of just, I want to be a computer scientist, you're going to be in the office. And I know we don't print often, but you remember how you like when a printer's free? Yeah, okay, so we do care about printing a little bit. Because ink costs money, paper costs money, right? And these things are typically hooked up to a network, right? Those networks require security policies to who can access from this, right? No one can magically connect to my printer here, except for me, maybe IT, right? But all this stuff has to get managed and operated. And when we start growing into scale, right, this is a small class relative to some companies that you will go work for, right? And as a consequence, right, all of those printers need to be managed and handled. And they may have different sort of labels to them. It's not just printer, but you've got printers that are black and white, printers that print color, printers that are heavy volume. For example, you've got some printers out in the library that probably get a fair share of use. But if I have my own personal printer in my office, probably has not so much use, maybe a minimal amount of use, right? And those types of different things. And so you can see, different locations, different kind of functionality, different volumes, different kinds of printers. But notice how they're trying to represent this. Ownership is what I'm trying to get at. They're having to draw circles, and I had to add all of these different, pointy things to indicate different categories of like everything. How do you try and manage this? And then here's where, you get really funky if you're thinking about this outside of just like saving the world. Look, security. How do you identify which one, which one got hacked and is printing out all the black pages, and wasting all your ink? And how did that vulnerability occur? How do you even tackle that problem, right? You got to start going through it in some way. So you maybe try and build out some kind of representation. But why I build this? So if we think about everything I've talked about, we talked about the idea of just events and that concept of time and taking time and now applying it to events. What kind of events? Well, specifically those events being ownership we'll get to the events in a second, but we have time, now we have events, now we have ownership, right? So we have 3 different categories. And then I presented printers. Time, events, ownership are the 3 things that I've introduced to you in those past few slides. And so what can I do with those 3 representations? Well, time. Oh, time. I think you might want to remember something from your 216 territories. It had a wonderful acronym, FSM. The finite state machine. That is a super powerful tool. And in fact, I might be able to use and represent these different things. So you can see suddenly, which printers, and in this case, I'm just kind of thinking about it as which printer is owned where. So where is a printer located, for an office? I need some way to determine that. I can do that through Prolog, but I also talked about this idea of finite state machines as well. You notice this is where, look at that. We talked about how, it's not super crazy AI, but the finite state machine, if you are using it and you treat a printer as if it was a thing that has its own tasks going on, well, the finite state machine for the printer, people start thinking that's AI. We understand it's a finite state machine. People, right? They start going, your printer can talk to you now. It's ChatGPT, right? It's going to print out hold on, I got to find a clean example. It's going to print something. That's terrifying. I can't think of a clean example. Anyways, my point being is this is where all of that work, all of that time and effort and that higher level thought process, some of the stuff that I'm presenting here, it's something that you can use graduating right away. Some of the stuff I'm teaching you in this course is also, for those of you who are thinking maybe grad school is an option, right? Some of you want to use AI, but you have, you want to kind of pick these really, really niche topics, like software engineering and security. Okay? Well, you need a place to do that, and academia will pay you good money to derive printers. My point being, right? So as we kind of think about it, right, I gave you an example for printers because it's just such a benign thing to try and represent and whatnot. But when we think about trying to build out these knowledge representations, what we're essentially trying to do is we do want it to have like all the important things, right? A printer and its ownership and its location, right? It's not a lot, because a printer has really one task. Maybe you want to know ink cartridges. But it should have all of the information that we do need to represent that space at the right granularity, right? That's where think about the printer. I know it's such a, benign. I'm gonna get really hyper-focused on printers now, right? You don't need to know maybe the inner workings of the printer and like what you don't need a sensor telling you if there's dust collection on the gears type of thing, right? Though that's too fine of representing your printers, right? You don't need to model every single component or electrical spring inside it, right? You went a little higher. You went to the right level of granularity where printer in location. That's fine. But again, you have to think about that for your domains as well, right? Again, if you're thinking sports, there's a very fine, you don't need to know the diet of your athletes beforehand, except you might. Some of you may want to go into like that whole area where you're doing data analytics for athletics, right? Because that's that's actually a thing people are doing. And so again, right, maybe you do need to know diet. Do you need to know the diet of your athletes if you're building, some kind of prediction algorithm on which team wins? I mean, maybe you still want, that's Moneyball right there, right? But okay, right, you don't always need it. And then there's that incremental development, right? You're not going to get it right the first time. Or you were too broad in your initial representation, and you found one of those moments where something broke or didn't properly represent things. So what do? You iterate. No different than what you do in software. We iterate in these ontologies, in this knowledge kind of domain. The problem, though, is when we start getting too fine with these details, it gets difficult, right? It shouldn't take it should not take me having an entire lecture on like the inner workings of a printer. I should be able to give it to you in, a broad stroke of like, oh, here was a 5-10 minute, rant about printers for a second, right? Should not take too much information, because at some point, if you take and use too much knowledge, you're trying to represent too many things, when you try then to explain that to people, this is the annoying part, the brains turn off. Just look at y'all. I see some of your faces. Your brain already turned. Thank you. Right? Your brain just turned back on because I did the meta thing where I acknowledged that you weren't paying attention. Right? The more information that you're throwing, people don't remember it. It starts going over their head at some point. So you need this kind of common balance as you're working through these things. And that's where I want to talk a little bit about Jeopardy. Specifically the IBM Watson moment. Again, IBM Watson, this was only 10 years ago. And we already, like, it boggles my, as I get old, right? It boggles my mind that, 10 years ago, we already had something that was beating and stomping humans, right? Ken Jennings. Y'all know Ken Jennings, right? Is this a thing? Okay, thank you. I don't know what you know anymore, right? Ken Jennings, explicitly, like in his final Jeopardy answer, was just like, yep, I accept it. All right, we're done. I for one, welcome our new computer overlords. Why? Because stomp them. Absolutely. If you've not sat down and watched the IBM Watson Jeopardy, again, 10 years ago, before ChatGPT ever came around, it was already terrifying what it could do with just like trivial knowledge. It does make some things wrong. I know at least back in that time, one thing that the scientists who built IBM Watson stated was it doesn't understand the concept of orange. Yeah, I see faces. Just go ahead. Think about that. Just you as a human. What is orange? The color orange, not the fruit orange. Just orange. Like what kind of feelings does it evoke? Especially now that we're in October. Pumpkin spice time, right? All those little things that we as humans, we understand to the context of what like really kind of encompasses orange. The computer doesn't understand that. It's just a bunch of numbers, right? Light theory happening and all this. So, right, it's really great. That documentary, strongly encourage you to give it a watch. I won't, I want to just confirm it's still there. Yeah, it is long.
Major funding for NOVA is provided.
Yeah, it is long. I get it. Think of it as just a bunch of stitched together TikToks. I know, I can make fun of you because I'm old now. I know, that site was called YouTube. It's for longer TikToks. Anyways, right? So, here's where, okay, all right. IBM Watson, incredibly powerful tool, currently being used to study and analyze healthcare and all of the medical journals. It probably has gone into other fields as well as time has progressed, but like after Jeopardy, that was what they were using it for. It's now just part of their entire field, and it's a thing that they sell. But specifically, built in C++ and Prolog. Oh, this ancient esoteric niche language, wouldn't you know it? We use it. We're using it to do all of that understanding. That thing that stomped our Jeopardy award winners, that's able to school those guys, uses the thing you know. A little bit, right? And it starts also introducing some of our next level steps. Now that we have essentially really dug deep into the concept of how an agent kind of problem solves or path finds and optimizes, as we kind of leave, we're not done with logic, but as we start to leave the logic territory, we enter into what we consider machine learning territory and high-level AI territory. And that's where you get something like natural language processing. And you can see, again, I got plenty of links for y'all in today's... I'll fix that one. That one worked, right? Oh, wouldn't you know it? Natural language process for Prolog programmers. And it goes into elaborate detail. If you've ever been really deeply interested in the concept of English, right? Of just like how English works and all that stuff. I'm trying to find a nice little graphic for you, right? There, look at that. You remember English class? Do they still do this kind of stuff in your English classes? What have we done with the youth? My point being, right? No, you break it down. Oh, look, a sentence. What is a sentence? Well, a sentence has its different structures to it, different ontologies, if you will, on what each part of the sentence means. So a sentence gets broken into the noun phrase and the verb phrase. And the noun, a noun phrase could have a determiner, a noun, a pronoun, a proper noun. What about the verb phrase? What could be inside of a verb phrase? Well, a verb phrase probably has some form of a verb, right? The subject to the thing, right? Oh, well, what else? Well, a subject typically has an action to a thing, and that thing just so happens to be another noun phrase, which could have its own determiners or proper nouns or pronouns or prepositional phrases. And, wouldn't you know it, that is... Trying to find some prologue for you. There, look at that. So there's your prologue of trying to implement those simplifications and whatnot. And so, yeah, you can start to tank it. And specifically, again, I keep on talking about this idea, and this is where we will talk more in detail about natural language processing a little bit later, but I want you to just... Here's a nice little answer from Jeopardy that AI has ruined my IBM Watson was able to solve. He was a bank clerk in the Yukon before he published Songs of the Sourdough in 1907. Boop, boop, boop. Question was, who is Robert W. Service? Robert W. Service. Next question. Anyways, no, my point being, why did I present this? Well, again, think about that. Maybe you in your brain, you have no idea. But what was going on? What was the process that you did as you pulled out that information, or you looked in your brain for your knowledge repository to try and understand all of these different things? Maybe you do know, right? It's 1907, so early music might be one of those things you're really into. And there's my wager. Why I present that is, think about how could I break that sentence down in a way that we could then gain better, proper, computational understanding to the structure of that sentence. There was, for example, what we call a lemma. Typically, lemmas are just like, those big important things of a sentence. And so, there was a term in there, he. He, that's a lemma. Okay, fine. And what kind of lemma is it? Well, it's a pronoun. And so you can notice that suddenly, by establishing two rules, I could establish that, hey, I'm going to just apply a number. That's my variable is a number. There is a thing one. That one, it represents he, right? We've done a very similar approach. Now, that one also was a part of speech. What part of speech, pray tell? Well, that part of speech was a pronoun. Okay, then let's keep on going, because you'll notice that we had another lemma, the verb. And what kind of part of speech was this to? It was a verb. Oh, excuse me. And then there was another part of speech specifically on Songs of the Sourdough, which was it's also a noun. And then you notice, if we were to be able to break down that structure of a he publish Songs of the Sourdough, right? The rest of that sentence, almost superfluous. Almost. Before probably is important there as well. But just, it's all this stuff because we got to make sure we're reading in English and it's right. Yeah.
I'm just thinking here. Would the program be able to identify the fact that the interpretation said that is one element?
So the question is, right. So the question is, would the program be able to see that Songs of the Sourdough, just to kind of present it, is one thing? That's actually something we will talk about a little bit later. That is open research, specifically called named entity recognition, being able to see where a thing is more than just a word. In this context, the quotes are probably being helped. I will say when they were dealing with IBM Watson, I'm trying to remember 10 years ago, I want to say it got text and the audio from Alex Trebek. I can't remember if it only got the audio channels or if it only got the text. And then that part I can't quite remember. But, it's a symbol. And so if we're thinking about it from just its strings and, character data types, right? I can see if I'm just processing it from, let me pick a good color. If I'm just processing it from a character representation, there are quotes. So a quote is all being attached to a single thing, whatever that thing is. So yes. Can you? Yes. Is it difficult? Also yes. Where was I? So again, that he that we established was a one, again, this is where I'm just pulling from that paper that I showed you. So the publisher, the subject of the publishing term is one, is the way you could probably read that. And the subject, or the object of the publish verb is Songs of the Sourdough. Notice, those are two separate things, but they had a commonality. The one, right? The two. So a thing, one, now has an attachment to a three through some verb two, and that allowed them to answer the Roberts service. Now, specifically, this gets into much deeper territory. Again, maybe you're thinking grad school. Maybe you're thinking grad school here right? Because it's NC State. You like NC State, don't you? Don't you? Exactly. Wolf. Oh my goodness. It's like a cult. Anyways, my point being, why I present that is I know we have a graduate natural language programming course. And specifically in that course, you learn about Jarofsky's miniature grammar, because this is just a small dose of trying to look at English sentences. Again, we're thinking of this as like traditional English sentences, correct English sentences, not verbal, dialogue, spoken English, or what some of y'all have posted on the internet, right? Those are actually new, interesting areas that we don't have proper models for. But at least when it's like, oh, let me grab academic papers or books and things like that, there's a certain kind of, rule, structure to sentences. Oh, well, a sentence may be a noun phrase and a verb phrase. It may have some auxiliary before that, right? And then be a noun phrase or a verb phrase. Or it may just be a verb, right? So I'm trying to think. Noun phrase. So a noun phrase, the man opened the door, right? Noun, verb, noun. Auxiliary. Trying to think of a auxiliary here. I'm blinking. Quietly, the man opened the door. Open the door. All three of those. Different, again, right, context, but all three of those were a sentence. Well, then you can see we can break down what the noun phrase could possibly be. Pronouns. Adam opened the door. Proper nouns. He opened the door. Determiner, nominal. Well, the, right? That's a determiner. And what's a nominal? I don't have it in the same color, but the, right? The man. The nominal again. Oh, this is where you get into the ugly stuff. Notice this part right here. Infinite loops. Welcome to English. Or that would be infinite recursion. My point being, you can see, big, elaborate structure. We have a class, again, on there that if you're super interested, there's a link to digging much deeper into natural language processing if you're deeper. And again, we will talk about it in a little bit more detail later in the semester. But right, now that I'm kind of building this out, and maybe I'm trying to tackle the Jeopardy problem, being able to provide the correct response to Jeopardy answers, oh, well, maybe, I could design out some kind of rule structure. That author is the author of some composition. Those are just variables floating in space. But then, well, I would need to establish that there exists some verb that, I would be able to deduce, and that the verb is, or the subject of the verb is the author. The author is, in fact, an author. The object of the verb is some composition, and the composition is some composition, right? All of that stuff comes into play, but then notice, as we start to build more of those structures, what does it mean to create a verb? Well, to create a verb means that it needs to be part of some speech component. It needs to be a part of it. It needs to be its own lemma, and it needs to be a verb-type lemma. And if it's a verb-type lemma, it needs to exist in probably my list of possible verbs, right? Right, publish, all of these different things that would allow me to deduce that, Robert Service was the author of Songs of the Sourdough. Because, notice, it's all these rules. You then can make the resolution happen. And in fact, that's what IBM Watson does. He was a blank clerk. You can see how we break it down into those individual structures. And you'll oftentimes see this kind of same structure when you're digging into the natural language processing world. Was technically his auxiliary, but I'm going to keep on moving on. So now that I've rambled for almost an hour, it's time for you to put your thinking caps back on. I'm going to give you a little bit of time. I'm going to say, I'll give you till 4 o'clock. Please give me your domain, 5 nouns to that, verbs and potential relations to it. See you in 5. Make them in first order logic. I know. And we are back. Oh, I completely got track. Anyways, let's take a look, see what you did here. Let me get rid of all of that nonsense. All right, so we got, okay, football, nice. Medical, education, security. All right, we're getting some fun stuff in here. Let me, just gonna pull it over that way. See what you got going on here. Shrink this down, carry the 2, question life. Okay, so I'm just, again, a lot of these things are not things I understand. That's not how medical, that's someone who does not understand how a doctor works. I will take the ambulance one. That makes a little bit more sense. The others are kind of, you didn't try hard on those. I'm looking at them. Those are bad. You made a bad choice on those. Let's see. So what we got going on here? Quarterback. Okay. There's a relationship there. Snaps. Okay. I'll take some of those. Snaps, though, I would say needs a minute or some kind of event happening, right? You've got that there exists some offense and defensive player, but right, there needs to. This is that process of you've just told me, one person's the home and away. That's all you've really said. You're not you haven't built the representation of what tackling is for this. You just sort of created a task and rules that these 2 things must exist, but like what rule are you applying that indicates that defensive player did tackle offensive player? Let's see, entertainment, made game, company grinding gears. I assume you mean that should be an X, but whatever. Let's see, is top score holder. Again, you got these variables that are not getting used. So again, that is a major issue coming in here. Let me find some, optimal, coming and going, person, why. Again, I would still add in a little bit that you have the basics down, right? You've established what the 2 things are, but you still didn't really give it that representation of what the rule was, right? This thing is flammable. It's a little bit, sufficient temperature. Now we're starting to get there. This one I'll actually take as a reasonable amount going on there. But yeah, some of it's not quite there. But here's where I can give you a little solace. 1, I only gave you like 5 minutes to do it. 2, trying to get this right is hard, right? You will be paid to be just smart and build ontologies for your domain of choice. That's kind of, some of academia. That's a little too high level for my interest, but, right, trying to get this stuff right at the correct level of detail that would be able to be usable. That's the part I want to kind of throw out there, not just doing it because I gave you this. That's incredibly difficult to do. These are things where I'm going to start peeling the curtain a little bit. You will see this again when we get into the natural language processing section, but let's just look at a sentence. I shot an elephant wearing pajamas. Okay, fine. Who's wearing the pajamas? Right? It's a toss-up, right? You don't have any visual, is how I want you to present this. You are just making a selection. Elephant would sound funnier. I sounds more reasonable, right? Those are interesting. But that also introduces some of the problems with trying to derive meaning from text. Who is wearing the pajamas, right? That based on the rules of our structure, how this sentence is built, it becomes much more difficult. Why that also becomes a problem is, what does shot mean, right? That is a term that is used in cameras or in photography, but also in guns. And so now, again, as you start to try and peel back these curtains of trying to understand meaning. Did I wear pajamas while I took a picture of an elephant? Or did I shoot with a gun an elephant that somehow was wearing pajamas, right? Both of those are, from this sentence, possible. But why I present this is the joke side, here's the real side. What is this individual doing? Because again, as we start looking at what we use AI for, right, it's not just to make fun of the English language, but it's also to try and gain meaning from our data, our input. And if you are a helicopter looking for individuals, for whatever reason, I think this one, I just pulled this up from the internet of infrared cameras. I think it's a suspect fleeing. But specifically, if you're, what's the context? It's not just I gotta look for bad guys, right? I'm trying to identify bad guys, and this is in a neighborhood area, right? You may not be seeing only one individual where it's easy to find the person, right? It may be that it is a person, but do you know what activity they are doing, right? I gave you context, so you now know magically it's bad person, right? I could have hid that. I could have hid that information, and now you're just trying to do recognizance work, and that becomes a major issue as well. And why I bring these things up is I do have, you see the BDUs around campus. We do have military people. Some of you maybe are oh, Lockheed Martin, Raytheon. Those are fun. And again, I caught bad guys. I'm all about it. So yeah, it's hard. How, think about the motions going on there, right? This is all, you're only getting that kind of input. Are you able to do gesture recognition off of this? Probably not, but also maybe a little bit like that. Can you track where they're going to be moving if you have that kind of information? Those are modern day actual real world applications going on there. But if that, made your brain get terrified of reality for a little bit, here's where I can help you relax a little bit more. This is from the book For Battlegrounds, Power in the Age of Artificial Intelligence. And specifically, it's how we get to see that, yeah, AI still has a lot of things to get work done. And you, select few, maybe the ones working on it. And specifically, 8 Marines, not a single one of them got detected. Well, how? How did they defeat this AI system with no camouflage? Oh, well, 2 of them just rolled for 300 meters. Why? Because if you train a model, this is how humans work. I'm not going to do a roll. I'm going to do a roll. Boom! No, you can see hey, it's someone hid in a cardboard box. You could hear them just laughing because the AI, right, it just heard nothing, right? It was a camera. So yeah, here's your joke. Snake, put a box over your head and you beat modern day AI right now. Yay! This is supposed to help save us. No, so only, again, this is, I just actually gave an interview specifically on bias in AI. And look, this is one of the things I talked about. It's just whatever you train it on. And so if the only thing you're training it on is normal human behavior, then you've clearly forgot what normal human behavior is. You just saw a doctor do a front roll, or what I like to call ukemi, right? That's not normal. I'm not a normal person. My point being, so as we keep on, as we're starting to wrap up, we're not done yet, but as we start to wrap up, again, this is sometimes what I've given you in the logic section and trying to use Prolog and whatnot. It will get you some places, but it's not quite there. Again, this is what we were talking about with that proof by contradiction and everything we tried to do in our last lecture. Is you're trying to just make a reason for things, right? You're trying to derive reasoning from this whole process, And it's very difficult. And in fact, yeah, it may not match how we try to think about the world or see the world. That becomes a big, hard, difficult process. So what are we, how do we kind of do this? Well, again, that's what the finite state machine was, right? That's what, you all built the finite state machine in 216. Really was just it's an if-then statement of what state am I in? And then if I get a certain input, move to a different state. And that, guess what? That works. That is actually quite useful. That's the secret to the sauce that you're not going to hear out there and the people who don't know how to build AI. Some of it is just finite state machines to smaller AI algorithms. Ta-da! We're not, that's how it all kind of works at the end of the day. But we do have to be mindful that, as we're starting to build these things and they make decisions for us, unintended consequences. Again, if you remember the beginning of the semester, I talked about how the Uber self-driving vehicle just decided not to move out of the way or brake, right? Something went wrong with the system. We build the image recognition stuff. So it's our fault, right? It's not the computer's fault. We didn't design the algorithm correctly because the computer, pretty dumb, only follows what we gave it. So as we kind of think about this is where, as we're kind of building these things out, when you try and tackle a domain, that's really kind of where I'm getting at with this, is, you've got to dig really deep. You've got to obsess over almost the entire concept of that domain a little bit to understand these different little things. And I know that's not a fun kind of thing, but this is where, okay, well, what happens if I'm not? What if I'm consulted, right? Maybe I go work for the AI, but then the AI is like, hey, we're partnered with Citadel or not Lehman Brothers, Robinhood. Those are financial companies, right? We need you to build something that works for stock markets and whatnot. Well, how do you tackle this? And you've got your entire process of you got to sit down and learn it. You've got to figure out how those different things work. But that last one, knowledge elicitation, that's actually pretty interesting, and I can give that one a very concrete example. You know how to program. So find one of your friends who does not know how to program. And specifically, you just solve something off LeetCode or some simple CS116 assignment, right, that you could do in your sleep without even trying. And have them stop you anytime they have no idea what you're doing. The answer is, or the reason why, is because when they stop you, you explain why you're doing something. And this is a process. This is a process that we as humans do to try and do to understand other domains that we're not familiar with. And for those of you who maybe have explored cognitive psychology a little bit, it's also called the Think Aloud protocol, or a very similar process there, where you just keep talking, right? As you do a thing, you continue to talk about what you think the entire time, because that is, eliciting knowledge. So just to see where I am on time, I'll just skip through. That's another example of ontologies for analyzing Piazza posts. This was one of my colleagues as we were both in the grad program together. So, building out categories for help-seeking behavior in students, right? My friend got a doctorate studying just how you ask for help. Then you implement them and model them. But I think that's all I got for you. So what I will say is enjoy your fall break. But I want that Connect 4 good. Have a good one, ladies and gentlemen. I will see y'all next week. Oh, I hate rolling on